Last week I showed you guys a new CNC machine we have and one of the parts I made. Today we're gonna be making some more parts. This is the part I showed you guys last week for the lower knuckle adapters. We're gonna need to make a couple more of these. I've been playing with the machine and getting some settings a little bit more dialed in. So this is pretty much just a rough version, but we'll make some more of those and I'll show you guys some specifics with that. Today we're working with this piece, making this. So minus the little offset piece up here for the spherical bearings, that was just something I did for mock-up. If you just take all the 3D printed piece, this is the top knuckle adapter that hang on, I'll show you. There's a hole in the top of the knuckle. It's tapered. We're just gonna have a bolt go straight through. So I need to make that taper a full, just straight bolt hole. Probably doesn't matter, but it just makes sure everything is centered up there and stuff doesn't start walking around. Because even though we'll have a nut on the bottom clamping it, I don't know what kind of forces are gonna be on this. So just trying to make sure it's all centered. This one is like twice that because of how far it has to reach down to cut all this out. So we'll see how well that goes. But first we gotta get this locked down and then I'll show you guys some of the settings. We have the piece all locked down. Also, I built this cool little table for it with some storage underneath. Obviously I didn't build the storage, but it was taking up our workbench. So I built that and now it has its own little spot. Some little, just drilled some holes for the tools that I use most often for the little hold down pieces. So that's held in there. Now we gotta move on to the settings. Settings are where things get a little weird. So the first thing you have to start with is telling it how big a piece of metal you have in there. The program I'm using doesn't have a way to just do a surface pass. So what you have to do is you tell it how big the metal is, and then you tell it, basically create a separate 3D model, which I have here. I don't know if you guys can quite see that. Import the model into the program, and the model that I've created is 0.2 millimeters shorter. All the other dimensions are the same, the length and the width, but the height is just 2 millimeters shorter. Then you tell it to offset your model on the lower half of that metal, because when it first imports it, it puts it in the middle of your stock of metal. So if my model is 0.2 millimeters smaller, it would put it in the middle, and I'd have 0.1 on top and 0.1 on the bottom. But then you tell it to put it on the bottom half of that stock and you'll have 0.2 on the top and it'll know that it can take 0.2 off the top. Hopefully I explained that right. It's all just a bunch of trickery to get it to actually just do a servicing pass because there's no way to tell it to just do a servicing pass. Once you have all that figured out, then you tell it what bit you have in the machine and how fast you want it to go. So you have a couple different settings. You have your feed speed, which is how fast it actually moves. So right now on a surfacing pass, a roughing surfacing pass, I'll do about 1,000 millimeters per second. And then you gotta tell it how far you want to go down, because of that 0.2, I can cut off 0.1 at a time and it'll do 2 passes. Or I can cut off the 0.2 all at once. For roughing, we'll do 0.2 just fully, and then what you can do is normally, like for steel, you'll do a roughing bit and then you can come back and finish it with a second finishing bit. For aluminum, I just use the same bit because it's the one I have in there is good for taking off a lot of material, but also if you slow down some of the speeds, it'll do a nice finish. So you basically, on the first pass, you just do really fast, really deep, and then do a second pass where you slow all the speeds down and it'll take its time and kind of really smooth out that surface. You also have something called step over, which is how far the bit moves over every time. Right now we're at about like 2 millimeters. And what that does is it just, same thing for roughing and finishing. For roughing, you want to take off as much material as possible. So you don't want to be taking, a million different passes. You just want to get the material off. Then for finishing, you'll lower your step over and do even down to 0.5, and it'll do just a bunch of passes really close to each other to get as much overlap as possible and give it a nice finish. Hopefully that's a good enough explanation. Not really trying to go too far into the software, but that's what we're working with. So I'm gonna load up the program and probably set up a time lapse so you guys can see it. It has trouble. I've tried to do time lapses before with this, and it has a problem staying focused on the piece, but we'll see how it goes. And you guys will see it, and then we'll come back and I'll show you the software that we have to use. Well, same software, but the settings we have to use for the actual piece. Before we start, I did want to just show the settings real quick. So right here, you have the step down, which is 2, so it'll move over 2 millimeters every pass, just to make sure. Our bit is 3.175 millimeters in diameter. So if you do 0.2, you have 1.75 of overlap. So just make sure it cleans up all the metal. Then you have your step down at 0.2. So I can put that at 0.1, and even though we're cutting off 0.2, it'll basically split it into 2 passes. So to do 0.1 and then go down and do another 0.1. We're just gonna take the whole thing off at once. Feed rate, I have at 800, sometimes 800 to 1,000 for roughing. That's just how fast it moves across the workpiece. Then you have your plunge rate, which doesn't really matter for us. I'll explain later why. Your spindle speed, normally I slow that down a little bit. So for finishing, I'll do 14. Roughing, I'll do 10 to 12. When you slow your motor speed down, it gives you more torque. So when you're taking off a bunch of material, you want to go a little bit slower. Tool number doesn't matter, and then those two don't really matter for us. Then you tell it kind of what path you want it to take, so you don't want it to just go back and forth. You want it to kind of go and spiral in or spiral out. What different cutting types, and then some boundaries that you can choose depending on how your cutting your work. And here's why the plunge rate doesn't matter for us. So plunge rate is basically how fast it digs in to the piece of metal. So like if you have 0.2, it'll have to dig down 0.2 and then start moving across. That can cause problems sometimes, more for things like steel, which is harder. But we have ramping turned on, which means it means the bit will over a distance actually go down until it's at 0.2. So it won't just go down to 0.2 and then start going. It'll kind of take like, I don't know, 10 or 15 millimeters wide and just kind of go back and forth to get the 0.2 and then go. Aluminum, I think it'd be fine, but I always have that turned on just for safety. The piece is done. It's got a nice little surface finish on it, so this will end up being the bottom. What is it? This, again, ignore this piece. It's pressed in there, I can't get it out. This surface right here is gonna be that. So we'll put it in there, and then I just figured out the programming for all of it. It's gonna cut down to this level right here, and then drill the center hole, and then drill on the outside. The one thing I'm worried about with this is the tapered contour. We don't have any small bits because it's so tall. I have to use a thick bit. They don't make like, you can get really thin, small bits that are like, you know, 0.8 millimeters or whatever to really get into like corners and stuff like that. And on this piece, it would have been nice to have a smaller bit to really get in those corners of the hex of the head. It still fits, but it would have been nice to get those corners a little bit farther pushed in, or not pushed in, but like pushed out. And you can only get a really large bit in there so much before it starts going outside of the contour that you want. But I'm gonna get this locked down and then load up the program, and I'll throw another time lapse up and we'll hope it goes good. Again, this is the first time I've used this bit and the first time I've done a tapered contour, so we'll see how it goes. Update, it's dark outside and the CNC is just now starting. I was having problems with the software that normally you run with this. It couldn't quite figure out the taper on the side for some reason. So I had to switch programs, which I've never used before. It took me hours to figure out, finally have figured it out. Don't even know if it's still gonna work. Again, I've never used this software, but the simulation makes it look fine. So we're gonna see. Again, also never used that bit, so we're gonna see how that works. It's gonna take quite a while, so I'm gonna time lapse it, but it may shut off. So you'll get to see some, but I don't know how long it'll last. Well, I'm not sure what random bits of video, time-lapse, maybe stuff you guys just saw. It's currently 4 a.m. All right, randomly woke up and decided to come check on it, and it was stopped at some point in the process. It looks like it cut us a decently fine center hole. It's not like the smoothest thing in the world. For some reason, when I tried to do the outside, it's something stopped. I think I was a little aggressive and didn't quite estimate how much this long bit would deflect. I think you cannot really do a rough cut with these bits. You pretty much just have to go in with your final settings, because your final settings for a finishing pass are gonna be really small step over and really small step down. So you're taking off very little material every pass. So things take longer, but you get a nicer finish. And I think for this bit, we just have to do that the whole time. I also, when I exported the file for it, Fusion 360 crashed and I lost the settings for this process. But I can recreate the file pretty easily and just do a final finishing outside pass, and hopefully that will fix things. The machine should go to the same place if I put the same settings in for here, so I'm not too worried about that. The machine's pretty accurate, so it should kind of, there's no reason it would be off from where it was before. So I'm gonna recreate that. I already ordered another bit because that was rough. It was cutting in way too far, way too fast. That bit is just not made for it. This machine isn't even that powerful compared to other CNC machines, and it was just moving that bit around way too much. Finally, after days and hours of work and many failed time lapses, sorry that there's probably gonna be none in this video because they all probably look boring. We finally have our piece, and it looks just like our other one. Now you can obviously tell it's pretty rough. I have a different strategy I'm gonna use for the other one that we use for this side, and if that goes well, we'll make a third one. Doesn't really matter, like I've said. All it does is it gives us a straight hole from a taper. So it's not even going to really be clamped or anything like that. It's literally just in there so the bolt doesn't wobble around in there. But with that long bit in there, plus the complications with the new software I had to learn on the fly, it's what we ended up with. But it actually goes pretty well inside the knuckle. So it does fit in there, pretty snug. And then on the bottom, you can kind of see that it's pretty much flush. So if we have to sand down the bottom, just because you want the bolt to ride on that, not the end of this. So if we have to shave that down at all, that's fine. I'm gonna work on the other one in my own time, just because you guys kind of saw how it goes. What I do want to show you though is what we're doing for this piece. I made this piece when I first got it and didn't film anything for it, and I think I have a better way to make it. It's honestly probably fine, but I never did a surfacing finish on the other side, and I'd kind of like to, just to see what it looked like with all of the CNC kind of bit lines on the whole thing. I think that just looks pretty cool anytime you have like a billet piece or anything like that. And I also want to do a finishing pass. So in this one, I just did a roughing pass, and it was super quick, and I went super far down on the step down. So what I want to do is do that again, because that'll take the most material away, but then do another finishing pass and see just how smooth we can get the surface. It's already pretty smooth. It doesn't really matter if we do it more smooth, if that makes sense. This piece already works. I just want to play around with the software a little bit, which honestly might kind of help us with this. So to start out with, just like the other one, we're going to do a finishing pass on the outside. That will become the bottom, which will become this side. That side actually doesn't look too bad. It's pretty rough in person. There's a bunch of kind of dings and dents in it, and all I did was sand it, so we can definitely get that a lot smoother. So that'll become the bottom, and then everything up here will be pretty much the same, but we're gonna do a finishing pass. And then one thing I wanna try to do, if we have the right bit, is to get down in here and get these corners a little bit more. The bit that we have is so large, it's not even that large of a bit, but it's so large that it can't really get all the way into those corners. And so the head of the bolt kind of is pretty tight in there. So what you do is you get a small diameter bit to really get in those corners. I just don't know if we're gonna have one that's deep enough for this pocket, so we shall see. Again, probably not gonna do a time lapse. I might try just to salvage something, but all the other ones haven't been great, so we'll see how that ends up. Well, as if we didn't have enough issues in this video already, I just woke up, obviously. We can ignore this. And I came down to it making a real weird noise, and we have a broken coupling. Now, the coupling is just to kind of absorb some of the shock between that axis of movement. When the bit starts to dig in, it's a spring-loaded piece, and it can twist a little bit. And just, again, take up some of the shock and vibrations. Not really sure how it broke. There's nothing indicating on the piece that it broke or dug in anywhere, so not too sure. Now we gotta find a new one, so I'm gonna get one of those on order, and then we'll get back to all the CNC stuff. But for now, we're kind of stuck dead in the water. I'm sure there's a million more things I can work on in the car, so I'll find something and keep going. The good thing is at the same place I'm gonna order that from, we have to order some more metal and some more CNC bits from, so not a bad thing to add to the order real quick. Just sucks that it's gonna take 2 or 3 days to come in. Anyways, hope you guys enjoyed the video. Hopefully I did some good explaining on some of the CNC stuff for people that are interested in that. Time lapses might not be great or there at all, just depending on how they end up. Some of them are real short, some of them are out of focus, just depending on what the camera wanted to do at that time. Other than that, I'll see you guys in the next one.